Today we're going to talk about where is the intersection between children's social emotional welfare and learning mathematics, and how the two are related. And we're going to do a series of activities where you develop specific skills for working with your students to help them build the resiliency that they're going to need to be successful in mathematics, and the skills that they're going to need to persist in mathematics, and frankly, the attitudes that are going to make them, we hope, like mathematics and want to persist in it. So I want to start the class out by asking you to look at a piece of data. It's right out of our data group. And I want you to take a moment and talk in your groups. I'm going to tell you this is proficiency scores on the CST. You have grade level and the percent proficient. And would you in your groups for a moment just practice that art of interpretation that was so well taught to us with the data group? In your groups, talk about what is this graph telling you about what's happening to children as they pass through the grade levels.
I mostly noticed like the decline instead of the incline.
Yeah, there's definitely a peak in 4th grade.
That's like that rapid decline from 4th grade to about, what, 6th grade or 7th grade? It's like a rapid decline.
Oh, it was even more.
And then it tapers off.
When they started algebra.
Yeah.
Let me bring you back. Graphs always have a story to tell. What's the story? Thoughts? What's the story? What's this graph telling us about what's going on for children in mathematics? Yeah, Marika.
Well, here it's telling us we're building up children to math in the lower grades. There's more hand-on materials, it's more interactive. The children it's a more positive experience for them, while once you get to around 4th or 5th grade, it's drastically downhill. Then it's more math, just let's teach the book, go on, no hands-on, no activity, no nothing, and it's scary for them.
Yeah. Other thoughts? Yes. Yeah, Jessie.
Well, we talked about as a group that it became more seat work orientated, and also that there was this sort of stigma as you got older that is it cool to be asking these questions, or even is it smart to be asking these questions, and that you might be isolated from your peers because of that. But where in like 3rd grade you can ask the silliest question and it'll create the most interesting conversation between you and your students.
And you're saying that somewhat shuts down in the upper grades all too often. I'm going to use your comment to segue into where we're going to go today, which is, while this looks at mathematics achievement, you might say learning. If we drew the graph would look just the same if we looked at children's dispositions towards doing mathematics for many of the reasons that you've pointed out. It also gets harder. It also gets more language bound. But kids are also beginning to think, I can't do mathematics. Maybe I'm not good at mathematics. Maybe I'm not the math person. Their attitudes towards mathematics, their motivation to do mathematics, their belief that they can be successful in learning mathematics, that line is the same for those dispositions. So when we talk about why we would teach some of the social and emotional learning skills to help children develop good attitudes towards math and have the skills to succeed in math, and by that I mean also the social emotional skills, they are intertwined with how children learn mathematics. And that's where we're going to go today. And we're going to start with just a brief exercise where we look at how does this play out in math? And many of you have already alluded to it in your comments in terms of, do children feel safe to ask questions? Do they feel like, in my math class, I can take a risk? It's okay. Do they feel like they can grapple with uncertainty? So I want to say, when we talk about why would it be important to teach social and emotional learning skills, I'm talking about specific domains of social and emotional skills that will help children in life and also in mathematics. Self-awareness and regulation, that we can work ourselves through a task that is uncertain. Social skills, that we can communicate with each other, that we can build relationships, that we listen to one another, that we can trust one another, that we can form a classroom community, and even decision-making intersects with mathematical problem solving. What happens if I take a path and it doesn't work? I need to examine my strategies and take a different path. These social emotional learning skills are embedded in how children will do math. So let's take a look at how one set of them plays out. We're going to start with emotional awareness and regulation. And I'm going to show you a problem, and I'm going to read it out loud to you because sometimes it's a little hard to see the screen. And rather than asking you to do it, I want to ask you, how does this problem make you feel? Okay, what's your emotional reaction to it? So here's the problem. And it starts out saying multi-step problem, which I want to say are words that strike terror into the heart of any 6th graders. Multi-step problem. The density of a substance is the ratio of its mass to its volume, written as a unit rate. Calculate. A 500 cubic centimeter sample of seawater has a mass of 514 grams. Find its density. A 300 cubic centimeter sample of an iceberg has a mass of 267 grams. Find its density. Compare. Which is denser, seawater or an iceberg? Explain why your answer is reasonable. I want you to talk in your groups for a minute, and really I just want you to look inside yourself and be aware of what emotions are you feeling right now. If I said, go do it, guys.
This was a problem in your book, like we discussed in a previous class, where you can take a story problem from the book and make it more interesting. So even as simple as, even if an iceberg doesn't relate to them, try to at least, you could pull in a story about the Titanic.
I would have melded science and math together. Like, let's try this experiment. Like, what do you think is more dense? And you have like 3 different objects, you know what I mean? And then you have like, well, what do you think? And then we can actually do the measurements and the calculations with them. And it's more meaning, because then they can actually take that home and go home and be like, well, I wonder what's this? And it's building your science, building your math. It's the whole, everything common core that we're all working towards.
You guys are picking up on the importance of relevance in mathematics, and that's critical. But I also want to say you're going at it like teachers. What are you going to do? And I want to push you instead to say, what is your emotional reaction to the problem?
We started with anxiety, and that's why we got led into how we would make it less, instead of all this vocab and so much text and numbers thrown at them, you know.
So this is good. You just can't stop being teachers.
Yeah.
I will say, like, as a student, like, when I was in 6th grade, I just remember there was a very strong, like, science when I was in 6th grade, and I would have looked at the picture and said, well, obviously the iceberg's less dense because it's floating in the seawater, so I wouldn't even have tried to calculate anything. That would have been my rationale, and
Which would have been very smart.
She would have found a way to
it doesn't say show your work, so
We'll get to that later. But your initial reaction was you're saying anxiety. Because of what?
Well, for me, the multi-step. So I'm already thinking to myself, oh, this is going to be hard.
Yeah.
Just because they wouldn't have said that if it wasn't really going to be hard. Hard. So then it has these 3 steps, and there's so many. I can just glance at it and see there's a bunch of numbers. There's a bunch of vocab. I have to remember density versus grams versus sample and where I'm putting those into a formula, and I would start to panic before I even worked it.
So let me call the class back. What were some of your emotional reactions to that problem? And I'm really talking your emotions. Don't tell me what you're going to do as teachers. That's coming. It's coming. But what was your emotional reaction? Because I want you to feel what kids feel. Yeah, go for it.
First looking at this, scary. And the first thing we talked about in our group was our second language learners.
Absolutely.
Looking at this problem, pulling out every word, you would have to sit down with them and explain to them. And just having them take a test like this or look at a problem like this, they would have not a clue where to start, where to begin, anything.
This is not a problem you should give children to do alone. It just strikes terror into their hearts. Absolutely. And indeed, when I did this problem with kids, one of the students several of the students I was working with said, so many words, just too many words. I see the word calculate too many times, and the numbers are really big, and I'm scared. Yeah. Okay, here's what I want you to do next. And I think we'll just talk about this whole class a bit. As teachers, you recognized your emotional reaction to the problem, and you're aware of it, and you can articulate it really well. But as teachers, you go beyond that. You know how to talk yourself into doing it. And so what I would like you to think about for a moment and talk in your groups is when you are given a problem like that, in that scary situation, what do you say to yourself to get yourself to try it? Because you wouldn't have made it this far in your education unless you were really good at that. So how do you cope? What do you say to yourself? Talk in your groups for a minute, and then I want to pick up on that.
Just because density, volume, cubic centimeter, those are big words, and I don't think 6th graders would really know what that means. My 6th graders wouldn't know what that means right now.
Definitely, even just adding like little symbols, what they normally would look like, in a problem, like grams would be G instead, or cubic centimeters would be centimeters with a little 3 exponent. that kind of stuff and make it more familiar for kids to look at.
Once I've gone through and I realize what all the words mean throughout the problem, I'm very systematic in my approach. I would go from the very beginning, what is the first thing it's asking me to do, and just focus on that. Before even reading farther down, I would focus on one thing at a time, making my way down that huge word problem. And yeah, so
You know, a lot of things, what you're saying too, a lot of kids will just look at it all and just start trying to figure it all out as one big problem and not breaking it up, because that's what they think they have to do. They think they have to look at the bottom of the question and what is it asking me? And they'll completely lose themselves.
Yeah, exactly. Lose themselves throughout the whole process. But when really the question usually builds on each other. The first thing's asking what's one thing, and with that, you're able to trickle down and answer.
So what are the things you, as successful teachers, say to yourself when you encounter a problem that really scares you, that makes you anxious? What's some of the ways you talk to yourself? What do you say to yourself to get yourself back in? Don't tell me how you teach it. Tell me what you say to yourself to engage. Yeah, Brianna.
Well, I take a deep breath, because looking at it, like I told my group, makes me anxious.
Yes.
And I take a deep breath, and then I notice things about the problem that'll help. I didn't like the fact that it said multi-step problem. That made me anxious. But now I see that because it's broken down by A, B, C, I have somewhere to start. And for all I know, I can't do B till I finish A, so there's no point looking at it. And I just sort of talk myself through, just start with A, get through it, and see what happens next.
So you're saying, I take a deep breath, which is literally how we can calm ourselves down. And then I want to say you also gave yourself permission to take your time. And then I heard I'm going to go step by step. I'm just going to take it one step at a time. Really great what we call self-talk strategies for thinking, okay, how am I getting myself even willing to attack this problem? Any other things that you all say to yourself? Yeah, go for it.
I actually liked what Steve said when he looked at it and he said, challenge accepted. And I kind of like teaching that to students to look at it and say, okay, challenge accepted. And then kind of similar to just break it down. How do you eat an elephant bite by bite? So just one step at a time. But to have more of a positive attitude of like, yeah, this is challenging, challenge accepted. I'm going to go ahead and take it.
I love that. I love the idea. And I don't think it's going to come instantly. I actually think we have to teach children it's safe enough to say challenge accepted, which means challenge accepted. I might be wrong the first couple of times. I might have to change my strategy midway, but challenge accepted. I'm going to go at it. Here's what I want to say to you all about how you talked to yourself. You had these wonderful strategies for getting yourself to go into the problem. I took, because I'm really trying to research how could you teach children to do what you all do so well. So I took it to a classroom and I worked with a bunch of middle schoolers, and I did exactly the same thing. I gave them the problem and I said, and I want to say in 30 years of teaching math, I actually had never asked this question, how does this problem make you feel? And they sort of looked at me oddly, and they were silent for a moment, but then they let loose. And they told me all about how this problem made them feel. And my favorite response was, one girl said, this problem brings out the run response in my brain. Another one said, I freak out. One of them was angry. It's like, what the heck? It was just, others were just hopeless. I can't do it. What if I'm wrong? And once they started talking, it was like floodgates. And one of the things that happened is they heard each other talk about they were anxious. It made it okay to be anxious, which is the first step to self-awareness. So then I said, well, what do you do to talk yourselves through it? And this is where we really hit the wall, and it was an important finding for me. They said, we don't. What did it say? We raise our hand, we ask the teacher for help, we stop, that we refuse, but they didn't talk themselves. So then the question becomes, how can you teach kids to do this? And what I tried to do is teach them to use the strategies you just articulated so well. So we took a deep breath. And it was sort of funny. I said, did that help? They were like, okay. Well, first of all, let me read it out loud to you. Because if I read it out loud, we're not struggling with the language so much. And after we do that, let's give ourselves lots of time to do this. Let's do it as a group so we can help each other and each throw in the things we know. Let's go a step at a time. Let's look at the clues in the problem. What do you guys see? And somebody noticed, you know, there's a picture. And interestingly enough, somebody said, ice floats. I was like, well, there's a really relevant piece of information. I said, who knows, let's pull together what we know. Who knows what density is? And indeed, one of the students in the class went and grabbed the stuffed animal from the reading center, and they said, well, okay, density is how big it is in relation to in relation to like how much it weighs. So we agreed their math book was, pardon the pun, really dense. And the stuffed animal, not so much. So we sort of generated, what is this density thing we're talking about? They put it together with ice floats. Somebody else then said, well, wait a minute. If ice floats, it's got to be less dense. And I just, all the way along, all I was doing is encouraging them to keep putting together what they knew. And if ice floats, then it must be less dense. And what happened is the children started getting a little more confident, very eager to pool their information, and they started to solve the problem. Indeed, I said to them, you know, you already have solved the problem without actually doing any math. You have answered the question. And they were like, ha, beat the system. But I just say, but it does say unit rates, and we had studied unit rates. The only part where I had to help them was in setting up the first ratio. After that, they set up the next one, and the child who said, I freak out when I read this, he was the one who said, I'm going to calculate the unit rates to just prove that we're right. It's like, good math day, when a student who freaked out says, I want to prove it now by my calculations. And he did. The final step in this lesson was I asked students, reflect on how this went for you. And they got it. They said things like, if I hadn't freaked out, I could have done it. They said it actually wasn't that hard. I knew the parts of it. It was just too many words, too many numbers, the multi-step label. And when they reflected on what their initial emotional reaction cost them in terms of not pursuing the problem, what we talked about is, could we try and take these strategies now to other problems? And one of my big points today is I teach these things in the context of the math I'm teaching. So a month later, I'm going to choose another intimidating problem where there's clues in the problem, but they've got the pieces, and we're going to all together walk through this process again. What I'm trying to get them to do is internalize these skills for, it's okay to freak out, but then I have to talk to myself. Then I have to get myself to a place where I might say, challenge accepted. And when kids do, that's when they learn. And if you want to teach that, do it in the context of what you're teaching so that it fits with your curriculum. But also, when I taught this problem, I wasn't teaching unit rates. I wasn't teaching about ratios. My learning objective was to teach emotional awareness and regulation when faced with uncertain problems.